Hi, my name is Eric Hankey, and I'm a digital design engineer at IntelliProp. Today I'll be giving a demonstration of our IPA-SA-129-CT SATA solid-state drive controller and reference board. Before we get into the demonstration, I'd like to give a quick overview of our jumbo board and its capabilities. At the top of the board, you will see a standard SATA and power connector. The IPA-SA-129-CT Apache SSD controller resides in the center of the board. At the upper left corner of the controller, you will see the DDR3 memory. This memory is primarily used for storing cached translation tables for the controller flash translation layer. Surrounding the controller, you will see 8 NAND chips on the top of the board, with another 8 NAND chips on the bottom of the board. The IntelliProp Apache firmware development board is ripe with debug capabilities, including a GPIO header for event-driven task control such as tamper detection, loss of power events, as well as controller status. An LED bank which provides additional controller status and error reporting. An I2C header for connecting low-speed peripherals such as EEPROM and environmental sensors. Configuration switch for selecting between a variety of configuration options. Current sense circuits for power and performance tuning. An RS-232 DB9 connector for interfacing with integrated debug monitor. And a JTAG interface for chip-level configuration and debug. Now that you're familiar with the Apache Jumbo Board features and capabilities, I'd like to showcase some of the performance available on the controller. To do so, I'm going to run a benchmark in a standard operating system. First, I'll select the Apache SSD and then start the benchmark drive option within the disk utility. This test will run both writes and reads, and you'll see that the average read performance is 530 megabytes per second. The average write performance is just over 530 megabytes per second. You'll also notice that the performance is very consistent. This is due to the hardware automation architecture within the Apache solid-state drive controller. There's very little firmware intervention required for standard data commands. You'll also notice that this very high consistent performance is available for both compressible and incompressible data types. When the read-write test finishes, you'll see that an access time test will be run. This is showcasing the average latency on the drive. You'll see roughly 100 microsecond access time. It's very consistent due to the hardware automation within the controller. Next, I'd like to show you some of the capabilities within the Apache Debug Monitor. To do so, we're going to switch to a screen capture. The Embedded Debug Monitor provides the Apache embedded software developer with a variety of debugging options, as well as statistical data on the current health of the drive. Some of the capabilities included in the Debug Monitor are an ability to perform a secure erase of every NAND block in the NAND array. This command erases all blocks in the NAND array and initiates a rebuild of the internal table structures. This process takes less than 5 seconds. An ability to monitor smart data counters and perform short and extended self-tests. There is also the capability to force errors to be recorded in the smart logs for testing and debug. Additionally, we can perform validity checks and monitor the current state of the NAND flash translation tables. In addition to these debug monitor capabilities, the Apache SSD controller offers a mechanism to read NAND pages with the ECC enabled or disabled, as well as AES encryption enabled or disabled. This direct NAND access allows for direct interrogation of the raw data stored on every byte of the NAND by a security officer prior to redistribution of a security erased drive.
Thank you for taking the time to view this demonstration of the IPA-SA-129-CT Apache solid-state drive controller. If you have any questions, please contact us at info@intelliprop.com. Thank you.